Whoa, there's so many faces. This is awesome. Right, hi everyone. I was going to introduce myself, but I've already been introduced, so I'm Cassie. I work for a company called Clearleft in Brighton, and I have the pleasure of being here today to talk to you about SVG. I also make cute stuff like this on CodePen. So I wish I had time today to talk to you about all of the exciting possibilities that we have with SVG, but I've only got half an hour. So I'm going to focus on SVG animation, which is my favorite bit, and I'm also going to chat about how playing around with SVG has helped me explore some other areas of front-end development. So right, let's get the show on the road. Firstly, what is SVG? A lot of the clues in the name. So SVG stands for Scalable Vector Graphic. It's an image format that's scalable because it uses maths to plot and connect points rather than being made up out of pixels. So you can make SVG tiny or massive without affecting the resolution or file size. It doesn't mind. But SVG isn't just an image format. It's also a markup language. So after you get past the initial confusion of all the ones and zeros, it starts looking quite familiar. So it's got angled brackets and nested tags, quite like HTML. So in fact, it's quite a lot like HTML. I really love how my friend Richard explains SVG. He says that SVG is basically an alternate universe version of HTML, focused on graphics instead of documents. And just like HTML, SVG has a DOM. So unlike other image formats, we can actually interact with elements inside of an SVG and style them and kind of move them about to make animations. So yeah, SVG graphics are basically illustrations that you can manipulate with code, which is super cool. So some of you might be thinking that you can style HTML elements to make animations too. And that's a very good point. You can. In fact, some people make brilliant animations using HTML elements. So Julia Muzafarova made this using divs and CSS, which is mind-blowing. But just take a minute and imagine how complicated this would be to work collaboratively on something like this. So imagine getting a mock-up of this from a designer and then having to recreate it using divs. It would take a while. HTML in this case just isn't the right tool for the job. So Sarah Drasner says that SVG is built for drawing in a way that HTML and CSS are not. So by creating artwork with HTML elements, you're actually hacking things that are meant for layout, whereas SVG is made for drawing. SVG acts as a common ground, and it allows for collaboration and seamless handovers between designers and developers. So the designer can create an illustration with SVG and then hand that same SVG over to a developer, and the developer can animate it. So they can both contribute to the same animation using the same file. And I mean, if you can design and code, and there's probably quite a few of you out there, seeing as it's a CSS conference, then you've got the entire process covered. The world of SVG is your playground. Basically, SVG is the best. It's just the coolest. But before I get overexcited, we're going to take a trip back to 2001, and I'm going to tell you how I got started making stuff on the web. Retro. So when I was 11, I would wait until my parents were asleep, and then I'd quietly sneak downstairs to use the family computer. So it was a dangerous game to play back then, because accessing the internet was kind of noisy. And if I managed to connect to the internet without waking up my parents, I would log on to Neopets. So who here had a Neopets account? Anyone? Yeah. I knew there'd be some people. Brilliant. So Neopets was the best. If you weren't lucky enough to have a Neopet, I'm very sorry that you missed out. But it was an online game. It was kind of similar to Pokemon or Tamagotchi. So you could adopt a little fantasy creature, like this little guy, and battle other people's Neopets and play games and trade goods in a stock market, even. But the bit that I found the most exciting was the customization that the game allowed. Neopets didn't just allow us to customize our pages, they actively encouraged it. So there was a super accessible, friendly HTML guide on the website that talked through everything that you needed to know. It's still live now. It's a little bit dated, still using tables and background sound elements. But at the time, this guide was brilliant. Young people everywhere learned how to code. And the guide also encouraged people to make their own custom background images. So we also learned a bit of design. I mean, if you can call Microsoft Paint design. So for me and many other youngsters coming of age at the same time, this was our first introduction to concepts like coding and design. And I think that the sense of community and the knowledge sharing and the drive to create was what drew me towards front-end development as a career in the first place. But front-end development has got very serious. We've come a really long way since the days of Neopets. It's not all marquee tags and sparkly cursors anymore. We've had a constant stream of new devices, and increasingly large and complex sites have come in hand with complicated build tools and JavaScript frameworks dominating job postings. Front-end seems to be ever expanding and shifting further into the realms of computer science. It's a lot to learn nowadays. And without things like MySpace and Neopets, we've lost a lot of these original entry points into the field. And with the expansion of the field has come a little bit of a division. I think Chris Coyer, he wrote a great article recently called The Great Divide, and he mentions a rift that seems to be opening up between people that identify as front-end developers, yet have divergent skill sets. I've heard it being referred to as the front of the front end and the back of the front end. And now, this divergence, it makes a lot of sense, because front-end development is a perfect equilibrium between design and logic. And the career appeals to a wide range of people who are both visual and logical, and whose skills and interests fall over different areas of this spectrum. And it's really important to remember that people learn in different ways. So I organize and coach at a weekly coding workshop called Code Bar. And we found that some of the more visual students can initially struggle with a more abstract approach to coding. So they learn best by making things, and coding concepts click for them when they've got something visual or tangible to hold on to. So SVGs are a really great starting point for visual people who are learning how to code. It provides this really great bridge between something visual and the more abstract, and it works as a fun starting point to kind of play around with new web technologies. So let's take data viz, for instance. Has anyone had the pleasure of flicking through this book? Yeah, a few people, great. If you haven't, go and get a copy, or just check out their site. Information is beautiful. It's really inspiring. So after having a look at this, I felt really inspired to have a go at data viz myself. And a JavaScript library that gets mentioned a lot for data viz is D3.js. But if you've delved into the docs a little bit, you'll realize that it's also got quite a high learning curve. So Martin Birch says it best. He says that the trouble with D3 is that to build a visualization, you must also have a deep understanding of SVG, DOM, JavaScript, geometry, color spaces, data structures, the standard model, and quantum physics. So it's an amazing tool, but there's quite a high barrier to entry, even though you can do quite a lot with it. So for a lower barrier to entry, maybe before giving D3 a go, we can do data viz with just SVG and plain old JavaScript. So Robin Rendell's written a really great article on making charts with SVG. And he says making a chart with SVG can be as easy as designing one, exporting it as SVG, and then popping it straight in the markup. But the question that I had was, why stop at charts? You know, data viz, after all, is all about telling a story, and a picture speaks 1,000 words. So at Clear Left, where I work, we had some solar panels installed on the roof. And these solar panels came with an API, which was really exciting. So for Earth Day, I made a little illustration of our office, and I used it to show off our power savings. So we saved 4.5 trees worth of CO2 so far, which you can see in the little rooftop virtual garden. And the windows of the building also light up to show how much power we're storing. It's only at 33% because I live in England, so we don't have all of the sunshine like you do. So yeah, if you want to explore making your own SVG, there's a lot of graphics editors out there. I personally use Illustrator, but Adobe software is undeniably expensive and not accessible to everyone. So I asked the internet for some cheaper alternatives. Figma and Inkscape, they're both free, and they got a lot of love. Sarah Swadan recommends Inkscape as it generates the best quality SVG code, which is arguably the most important thing. So if you can't spring for Illustrator, then I would go with her recommendation, because she's the boss when it comes to SVG. And there's a lot of tutorials out there, too, to help you get started with designing vector graphics. But if you're not up for making your own SVG illustrations from scratch, that's also OK. So you can download vector art online from places like FreePic, and you can use that as a starting point. So yeah, FreePic's a really great place to go to find SVGs to play with. You can download them for free, as long as you remember to credit the artist. They've also got a really cute animation on this page, which I love. Sad, so sad. Ah, yeah. So if you credit the artist, then they're happy. It's great. Right, so now you know how to get an SVG. We're going to break down what you need to know to make a little animation. And we're going to animate a Neopet. So for those few people in the audience who had Neopets, this is going to be very exciting for you. The rest of you will just play along. Yeah, so if you're working in Illustrator, I find it's really helpful to plan out an animation using individual artboards. You can kind of see what's going on a bit better if you do that. But we only want to be working with one SVG, though, so we don't want to export them all individually. Once the animation's all planned out and you know what bits you need, you want to collect all the bits from the individual artboards into one SVG and then export that one out. And then once you've got your SVG, whether you made it or whether someone else made it, it's important to clean up the code before you start animating. So SVG code straight out of a graphics editor can be really bloated and very confusing. I personally really love SVG OMG for this. It runs in your browser, and you can see the changes as you go, so there's less chance of accidentally removing something that's actually important. Once we've done that, CodePen is a really great place to start making SVG animations. There's a brilliant community on there. There's tons of examples to explore, and you don't have to faff about getting a project set up. You can just jump straight in and start coding. Once you've got your SVG into CodePen, you'll want to do like a little bit more organizing. If you want to apply the same animation to a group of elements, to one or more of your elements, then it's a good idea to group them together and then animate the containing element. It's very easy to get into a muddle here, though, because SVG elements have an implicit drawing order, and Z-index doesn't work in SVG. So the shapes that are visually on the bottom of your SVG, like the wings, need to be on the top of the SVG code. Right, so animation time. CSS is a great place to start. You don't need to add any libraries. Syntax is nice and declarative. You all know it. You can reuse keyframes on multiple elements. But if you want to make something complex, like that amazing animation I showed you at the beginning of the talk, it starts getting a little bit messy. So with CSS, we can't chain animations one after another. Kind of have to fake chaining with delays. So if the first animation is 2 seconds long, we'll add a 2-second delay to the second animation, so it starts after the first one ends. But then if we want to add a third animation, we have to add the duration of the first and the second animations and then use that to work out the delay. And so on for every animation that you add on. And animations are never finished the first time. There's always going to be tweaks, and there's always going to be alterations. So working like this, it's an absolute nightmare if someone comes along and goes, could you just speed that little bit up just a touch? Like, oh, I have to change so many things. And also, sadly, when it comes to SVG animation, there's a downside to using CSS. So currently, transforms applied to SVG elements can behave differently in different browsers. This is particularly frustrating because transforms are so fundamental to animation on the web. They're how we move things around. So the issue with transforms in SVG is down to how transform origin is implemented. So DOM elements measure transform origin from their own top left corner. But with SVG, in some browsers, transforms are measured from the SVG canvas itself. So there's a relatively new property called transform box, and this looks really promising to fix this issue. But the browser compatibility isn't great yet. It's not quite there. However, luckily for us, there's quite a few JavaScript animation libraries that have solved these issues for us. So there's a lot of them out there, and they all do lots of different things, but these three are some of the most fully featured and the most popular. And all of these libraries handle SVG transforms consistently cross-browser. Hooray! GreenSock and Animate also give you the ability to organize your animations using timelines, which makes chaining and sequencing a lot easier. Velocity uses sequences and doesn't have a native timeline. You can add one on, but I find it a little bit harder to work with. In terms of weight, Animate is the most lightweight, and GreenSock is definitely the heftiest, but GreenSock is also modular. So you can kind of pick and choose the bits that you want from the GreenSock libraries to cut down on file size. Licensing-wise, Animate and Velocity are both MIT licensed, so you can do whatever you want, wherever you want. And the GreenSock licensing model is often a little bit misunderstood. All the core GreenSock features are open source, free to use. But if you are selling a product to multiple end users, then you need a license. They also have a bunch of plugins, some of which are free to use and some of which are behind a membership fee. But I think one of the most important things for me is to be able to get help when you're stuck. So all of these libraries, they have really great docs and really great CodePen examples, but GreenSock also has forums. And these forums are very active, and they are full of people that are ready to lend a hand. So for me, GreenSock's helpful forums clinched it. I also found the syntax the easiest to pick up, but this is going to be different for everyone, and depending on what kind of project you're working on and what problems you're trying to solve. For me, I love GreenSock. So they also have a ton of exciting plugins. And I mentioned the membership fee for some of their plugins, but all of them are free to use on CodePen. You can do whatever you want with them. Yeah. So there's a few out there that they made that are made specifically for SVG, like Draw SVG. Draw SVG allows you to show and hide SVG paths. So this is the kind of thing that you can achieve with Draw SVG. It wouldn't be an SVG animation talk without an example from Chris Gannon. This actually was originally done by Salih Abdul Karim from Airbnb using body moving. And body moving is an After Effects plugin that allows you to export animations to HTML, JavaScript, SVG, and Canvas. But Chris remade it using inline SVG and GreenSock to prove a point that inline SVG animation is just as flexible as After Effects animation. We also have Morph SVG. You can make hippos from circles. Makes morphing between different SVG paths a lot easier. So you can use Morph SVG to morph between paths even when they don't have the same number of points, which is a little bit of a tricky point without using GreenSock. So these examples are from the GreenSock docs, by the way, so you can see how nice they are. Yeah, so all the cool features of GreenSock, they definitely warrant their own talk, but we don't have time for that. I'll do that another day. So we're just going to focus on the need-to-knows for now and get our Neopet animated. So before getting started, you'll need to add GreenSock to your project. On CodePen, you can add TweenMax in your pen settings, which contains everything that you need to know to get going. Once you've got that sorted, you're ready to start tweening. Good question. I'm so glad you asked. So tweening is short for in-betweening. So a tween is the name for a single movement in animation. This could be a movement in space from A to B, or it could be in state from one color to another. And the ease that you choose is what determines the timing and the spacing of the in-between frames. So things in the real world don't just move consistently from A to B unless they're in space and they don't have gravity to contend with. So easing is what brings your animation to life and gives it personality. One of the great things about GreenSock is that they provide a lot more easing equations than we get with CSS and cubic Bezier, so we can make a lot more interesting and realistic animations. They've even got like bounce ones, which are great. Clicker. Okay, it's my laptop. Cool, so in GreenSock, a tween looks like this. So there's a whole bunch of GreenSock methods, but most of the time you'll be choosing to animate to or from some values. You'll choose what you want to animate, and how long you want to animate for, and what values you want to change. And you can create individual tweens like this one, or you can take those tweens and you can sequence them together on a timeline. So timelines act a little bit like a container that you can place other tweens or other timelines into. And timelines keep your tweens all organized and give you more precise control over the animation as a whole. So timelines have a bunch of different methods that you can call if you want to speed it up or slow it down or reverse it or pause it. And GreenSock also has dev tools. So you can add neat little timeline scrubber if you want to debug your animation. This is very useful. I use this a lot. But let's take a step back from the tools for a second. Because the best thing about web animation isn't to do with the developer experience and the specific tools that we use. It's to do with the user experience. So when you animate on the web, other people can interact with your animation. So this adorable example is from Catherine Cato. I just love it. But being able to factor in external interaction brings a new level of playfulness and creativity that you don't get with traditional methods of animation. And we don't just have to stop with hover effects. We've got all sorts of super cool stuff to play with in the browser. like the web audio API. So speaking of which, I've made our little Neopet interactive. This is not at all a cheap gimmick to make it sound like you're enjoying my talk. But the more you cheer him on, the happier he gets. So, yeah, you ready? Give him a cheer. All right, I'll swap slides after you've cheered so he's not sad. Give him another cheer. OK, cool. It's heartbreaking. So we can also play around with interaction from a webcam. So this little chameleon that I made changes color when you hold different objects up. So under the hood, I'm getting the average color from the feed and then updating some CSS variables. He's very cute, isn't he? I love him. It can be a bit tricky working with pixel data, though. But I learned something that I think is going to help you if you want to play around and have a go. So to simplify it, in order to get the pixel data from a webcam feed, we draw the webcam feed to a canvas, and then we sample the underlying pixel data. But the array of pixel data that you get back is massive. There's a ton of pixels to work through. Like, we're talking about 1 million color values. So it's quite hard to work out an average from that. But what we can do is we can change the canvas dimensions. So we draw the image frames from the webcam to a smaller canvas, for example, 4 by 4 pixels. And you can also visualize that in CSS with image rendering pixelated, which is very cool. And then if you want to get an average color value from that, that's a much more manageable number of pixels to be working with. Much less than 1 million. And color detection, it's not the only thing that we can explore with webcam. So machine learning and things like face detection are becoming a lot more common and accessible. There's a lot of face detection libraries out there. I've used Face API in the past, which is built on top of TensorFlow, and that's brilliant. But, drum roll, did you know you can do face detection in the browser? What? Yeah, welcome to 2019, folks. So face detection is pretty computationally expensive. That's been a downside to all of the libraries in the past. But mobile manufacturers have been supporting it for a while now using hardware-accelerated detectors, like for Snapchat and things. So Chrome have been working on a shape detection API, and that accesses these and exposes them for us to use. So it's technically not out yet. It's behind a flag, but if you paste this address into your browser, you can enable it, you can give it a go, play around with it, and then give the Chrome team some feedback before they launch it. So don't worry too much about the code. It's all in a code pen, which I've linked to in my slides, and I'll tweet them later in case you want to check it out. But in order to give the face detector a webcam feed that it can analyze, you first have to get the webcam feed and stream it to an HTML or HTML canvas or video element. And then once you've got your feed and you've created a face detector, then you can call the detect method to look for faces. You can also detect faces in images or normal videos, but it's just not as much fun, really, is it? But it's really, really accurate. When I was testing it out the first time, I was convinced that it was broken because I kept moving out of the frame, and it was still seeing faces. But it was picking up a face in a poster that was on the other side of my room. It's like this big. It's insane. Doesn't work on dogs, though. I tried it. Even if they're cleverly disguised as human, fooled me. But when you give it back actual human faces, you get an object for every face that it finds. So each face has a bounding box showing the position of the face. And then you get an array of landmark objects for your features. And now I'm not going to pretend that face detection is all fun and games. Like, a lot of the use cases for face detection are quite morally contentious. But we mustn't forget to have fun with new technology too. In a world that's getting increasingly dystopian by the day, why not use our power for good? We can use technology to inspire, we can use it to educate, and we can use it to just make people smile. This little blob gets shy when you watch him dance. It's great. And seeing as it was interactive, other people can play with it too. So I love that I managed to get a bunch of grown-ups to take time out of their day to play peekaboo with an SVG. It's brilliant. And this young girl in the top corner, her mum's teaching her how to code at the moment, and this apparently inspired her a bit, which I absolutely love. So, to wrap this up, what I love the most about SVG animation is how it provides a link from the world of design to the world of development. I still find it really amazing that I can make something in Illustrator, pop it into a web page, and then just use code to bring it to life. So yes, front-end development may have gone a long way since the days of Neopets, and the amount of stuff that's out there to learn may feel intimidating. But we also have more technology to experiment with. We don't have to rely on marquee or blink tags or GIFs for animation anymore. We have SVG and GreenSock, and we've got ways to create interaction right there in the browser. And a lot of us here got into careers on the web because we want to make stuff, because we enjoy creating and tinkering. And it can be really easy to lose sight of this in the race to keep up and learn the latest things. So if you've related to this at all today, make sure that you don't lose sight of that motivation. Keep making fun stuff. And if you do, I would really love to see it. Thank you.